Hey everyone, I am Anish and welcome back to Prefusion. So today we will be solving the engineering mathematics question from gate 2024 of ECE branch. So like the questions were moderate only. If you know the formulas, if you know the concept, then you will be able to solve those. One question, like good question, came in the electrical set. We'll solve that in the next video. So here, let's start. So this is from the complex chapter. So here you have to find the closed contour integration along this curve for this function. So this curve is mod z equals to 3. That means the radius is 3. It is a circle. Okay, so if it is a circle, then we have to check if these roots lie inside the contour or outside the contour, the roots of this denominator. So here what do I see? I have two roots, z is equals to 0 comma 0 and 2. Okay, so all of them lie inside the contour. So roots lie inside the contour. Hence all of them will have a non-zero residue. Okay, so how to find the residue? Now this is for the repeated pole case. So for the repeated pole case, what will the residue? The formula of residue is something like this. Let's first let me like write it for let me write it for the repeated pole. So we have to calculate the residue. So for repeated pole, my residue for 0, okay, or I should write, let me name this as z1 and z2. So z1, okay, is sorry, I can write this as residue 1. Okay, limit as z. Now we have to make limit z tends to that pole. So that, like, that root is equals to 0, right? That is a repeated root over here. And sorry, what did I, and what would we have to do? We have to differentiate dd of z excluding that root, those roots, excluding the z square. We have to differentiate all of this, right? So this will be sine pi z, z minus 2. Okay, now what will be this? So let me go to the next page. So what will be my r1? R1 will be this denominator whole square, limit as z tends to 0, z minus 2 whole square, and differentiation of this sine pi z, which is pi cos pi z with respect to z obviously, times z minus 2. Okay, and minus, now this term will anyways be 0. This will be sine pi z times 1, which will be anyway 0 because sine pi z is 0. Okay, like at z equals to 0 is 0. Now you put z equals to 0, this is pi into 1 into minus 2 divided by minus 2 whole square. So this is like a minus pi by 2. Okay, now one thing I forgot to mention, they haven't given us any like direction, so I will assume counterclockwise direction. Okay, I don't know in which direction they have given the contour. So this is for residue 1, and residue 2 is simple only, it says simple pole. So simply limit as z tends to 0, or not 0, sorry, z tends to 2, and we have to remove this and find this residue. Okay, without this, find the value of this function. So it is sine pi z divided by z square. Okay, now simply if you put like z equals to 2 over here, it is sine 2 pi, which means it is simply uh, 0. So my answer will be simply this value of this integration, sine pi z upon z minus 2 in the into z square in the curve is equals to 2 pi I plus 2 pi I because I'm assuming in counterclockwise direction into sum of the residues. This is minus pi by 2 and plus 0. So this is equals to pi square I. Okay, so this is equals to pi square I. So sorry, minus pi square I. So this is my answer for this question. Now let's move on to next question. So next question is like very simple differential equation question. So they have asked, like they have given the complementary function of a particular differential equation. We have to find the differential equation. Now you recall like 3-4 cases for differential equation. When does this happen? When there is a term inside, or like t term inside this, and like exponential is multiplied to both of this. When does this happen? This happens when my roots are real and equal. Okay, these type of things I get. So here what is the root? Basically the root is this, right? Like root is minus 2. Root is minus 2. So like what would my differential equation be? So we have repeated roots. Okay, repeated roots of auxiliary equation. Okay, if you have repeated roots of auxiliary equation, that means d plus 2 whole square is basically equals to 0. Okay, now like this is the equation basically, so it will become d square, like let me do one thing, this will be m plus 2 whole square equals 0. So this is m square plus 4m plus 4 equals to 0. Now what will my differential equation be? So my differential equation will be simply this, d square plus 4d plus 4 times y equals to is it a function of t? Yeah, it is a function of t. So this will be equals to 0, and then I can write as uh, d square y dt plus 4 dy dt plus 4y equals to 0. So this is my differential equation. Or like how else you could have solved it? So what you could have done is, simply you will see in the options there will be second order equation only. So yeah, you have been given the function, you just simply differentiate it twice. From there also you can go. Like what you can do, you first find what is y of t. Y of t is a t plus b e raised to power minus 2t. Now you differentiate it first time, dy dt equals to, this will be minus 2 into at plus b e raised to power minus 2t. Like first I'm differentiating this, and then I will differentiate this. This will be a into e raised to power minus 2t. Now what is this? If you recall, what is this? This term is this only. So this is y of t. So this is minus 2y of t. So y dash of t equals to minus 2y of t plus a e raised to power minus 2t. Now you again differentiate this equation. If I again differentiate this equation, this is y double dash of t equals to minus 2 y dash of t plus this is minus 2a e raised to power minus 2t. Now like from here, this is 2a actually, 2a. Now from here, like what is a e raised to power minus 2t? From here we can equate. So it is let me just make some space. T. So you just replace this over here. Just hold on a second. Oh no, some like insect has came in my legs. So yeah, now what you do is, now obviously this is a lengthy approach, but if you are not able to recall in the exam or due to panic like this, also you can follow. So we can replace this. So this is y double dash of t equals to minus y dash of t, and this is minus 2y dash of t, and this is plus 2y of t. Okay, so from here what you can observe is, like your equation will become y double dash of t, this become 4 y dash of t, and this will become plus 4 y of t. equals to 0. Okay, so yeah, this is how you can solve, like we got the same equation only. Okay, like this is derived from that only. So yeah, like if you forget the cases, then you can solve like this. Okay, or some complex equation comes up, then also you can solve like this. Now let's go to the next question. This question is a bit lengthy. Simply, you have been given a matrix 1 k 2 1. Now you have to say which of the following are the eigenvectors of a. Like please don't mind my handwriting, because like I'm in a hurry right now. So which of the following are eigenvectors of a. So what you have to do, first you have to find the eigenvalues, then you equate the equation of eigenvectors. So what is the equation? So equation is a x equals to lambda times x. Basically, what is the basic meaning of eigenvectors? Eigenvectors means if I multiply a eigenvector, like if I multiply a matrix with its own eigenvector, then it will get simply scaled. Its direction will remain same, but its magnitude will change. It will simply get scaled. Okay, it will still remain in the same direction or in the same dimension. Okay, so yeah, now for that we need eigenvalues. So what we can do is, like this is a simple two cross two matrix. We can simply use a characteristic equation, or you can do that a minus lambda I determinant equals to 0, like that also you can do. I am directly going to the characteristic equation. Okay, so what is the characteristic equation? It is simply, for a two cross two matrix, you should remember this. It is simply delta square minus trace of a. What is trace of a? Trace of a is the summation of the leading diagonal elements, which is 2 lambda plus 1 minus 2k, 1 minus 1 minus 2k equals to 0. Okay, so this is determinant and this is the trace of it. Now from here, what are my eigenvalues? So simply the roots of this. So lambda will be equals to minus b plus minus b square. B square is 4 minus 4ac, so it is minus 4 plus 8k divided by 2a. So it is simply equals to 1 plus minus under root 2k. Okay, so lambda is 1 plus minus under root 2k. Now if lambda is this, then we have to find the eigenvectors for each of these eigenvalues. So simply use that equation, ax equals to lambda x. So what is a? A is 1 k 2 1, and x, let me name this as x1 x2. Okay, and lambda is let's take the first eigenvalue, and this is x1 x2. Okay, now just let me just find the relations. So we multiply this with this and this with this. So this simply will be what, x1 plus k x2 should be equals to 1 plus under root 2k into x1. x1 gets cancelled, so this is k x2 equals to under root 2k x1, or I can say x1 equals to x2 by, just hold on a second, k by 2. Is there, okay, k by 2 is not like this, so we will write it like this, that x2 is under root 2 by k of x1. So if my x1 is 1, then x2 will be under root 2 by k. Here, no, this is not the case, but this is the case. Like these are not the case because these are in 2k terms. So here, if my x1 is 1, then my x2 is under root 2 by k. Under root 2 by k. So this will be d. This will be d. Okay. So yeah, this is this. Now let's check for the second eigenvalue. So what is the second eigenvalue? 1k 2 1 x1 x2 equals to 1 minus 2k x1 x2. Okay, so now let's do the same thing again. So this will be x1 plus k x2 equals to x1 minus under root 2k x1. Okay, now what will happen? This one will get cancelled again. This time the difference will be x2 will be minus 2 by k x1. Okay, so again, like this time the option 1 will get correct, because like if x1 is minus 1, if x1 is minus 1, then this will be plus 2 by k under root 2 by k. Yes, this is correct. So yeah, this ratio is matching. Like here what will happen, here some c term will also come. C term will also come. Basically for any, like any real number c, this relation will always follow. So like yeah, it can have many eigenvectors. Okay, like these are independent, like it has only two independent eigenvectors, right? These two independent eigenvectors. Obviously, like if I put c equals to 1, c equals to 2, they are dependent with this one only. Okay, so yeah, two independent eigenvectors it has. Okay, so yeah, that is one thing. And that is the solution of this question. The answer to this question is A and D. Okay, so let's move on to this question. This question is just like a theoretical question. So you have been given a vector f bar equals to f1 plus f2 plus f3, and you have been told that the integration along f dot dr of f dot dr along a path is path independent. So you are going from point A to point B. Okay, if you go from here to here, or from here to here, or from here to here, whichever path you follow, okay, for the integration, it will be same. It is path independent. Okay, it does not depend on the path, which path I follow. Then what does that mean? If it is path independent, then like this will be a theoretical thing. So I will just directly explain it, that if my integration is path independent, that means my f vector is conservative, field conservative, as you know. Like electrostatic field is also conservative. So f is conservative. Now if f is conservative, that means my curl of f will be a null vector. Okay, it will be 0. So that is the first thing. Also, if our curl is 0, so we can write our f in terms of a scalar function, like gradient of a scalar function. Okay, phi can be any scalar function if our curl is 0. So these are the things. Now what they have asked, they have asked del dot f bar is 0. Now is this true? This is the divergence, so this is not true. Where like divergence is not 0, curl is 0. Okay, now there exists a scalar function phi such that f vector is del bar phi. So yeah, this is true, this is true. Okay, now they are talking about us the like the different components, like this f del f3 by del y will be equal to del f2 by del x, all this. So yeah, this is actually true. How is this true? Simply, if we expand this curl, so what is the expansion of this curl in matrix format? It is I j k. Okay, now it is del x del y del z, and it is f1 f2 f3. Now obviously this one is equals to 0, so each component, each I component, j cap component, k cap component individually will also be 0. Now if we just do this, so this will be del f2 by del x minus del f1 by del y should be equals to 0. I component should be equals to 0. So it will be I cap into del del f3 by del y minus del f2 by del z minus j cap del del f3 by del x minus del f1 by del y, and plus j cap del f2 by del x. Let me just take this like I'm just doing this in rough. Okay, del uh, del x minus del f1 by del y. This individual components should be 0. Okay, so from here what relation can we get? Del, sorry for the noise, del f3 by del y equals to let me just write this like this, that f of 2y, okay, I'm just writing it like this, equals to f of 1 z. Okay, is this true? Like here this is the option I have got it. If the options are different, then this option won't be correct. Like if we can see that f of 3y equals to f of 2z. Yes, f of 3, okay, again what did I do? Yeah, f of 3, this will be f of 3y, not f of 2, equals to f of 2z. This is correct. And like again this is also correct, that these two will be equal. So f of 3x should be equal to f of 1y, f of 3x should be equal to f of 1. Okay, again, sorry, this will be z. Okay, this is what happens like when you do work late night. Z. Okay, so this will be z only. So yeah, this is also true. Okay, like just be careful about these three mistakes. And again, f of 2x, f of 2x is equals to f of 1y, f of 1y, f of 2x equals to f of 1y. Yeah, so if the options are like this, then this is true. If the options aren't like this, then like it will be wrong. Now what is this? Now it is saying that the integration of a closed contour will be 0. Yes, if it is path independent, then the integration over the closed contour will be 0. If we go from point A to again come back to A, obviously it will be 0, because what, if it is path independent, then I can definitely go from like this also, like this also. So if I'm not moving anyways, I don't need to move. Here it is moving like this, but I can say that as it is path independent, I will not move. If I need to go from A to A, I'm at A itself, so I don't move. So obviously the integration will be 0. So this is correct. This is correct. Okay, so yeah, this is the answer for this question, BCD. Now let's go to the next question. Next question is this, where our row is this, okay, and u is this, and like it is given that, given this relation, relation is given. Okay, so like this is a density function and this is some u function, which are function of xyz. Okay, now how you solve this? Simply what you observe is, it is talking about the volume integral, it is talking about the surface integral. So volume and surface, what does that mean? That means we are talking about the what, Gauss divergence theorem. Okay, whenever volume and surface are present. Okay, so first what you do is you write this clearly, because here they are talking about the volume integration. So what I can do is I can write equals to minus delta dot pu. Okay, minus delta dot pu. Now we can take the volume integration on both sides. So if we take the volume integration on both sides, del p del t v equals to minus sign is in front, del dot p dot u. Now we will just check which one is matching. So if you observe carefully, so this one isn't matching, there isn't a minus sign over here. This one is matching, there is a minus sign over here. Sorry, I made one mistake. We have to obviously integrate with the here, as this is a scalar, this will be dv, this will be dv. So both of them will be like we are doing the volume integration, right? So here which option is matching? So like this option isn't matching, and this option is matching, right? Del dot, so this is del dot pu. So yeah, this option is matching, both of them are scalar. Yeah, and there is also a negative sign. So A is matching, this one was MSQ, so we have to again solve. So what is this doing? What we can do? This is like divergence with dv. So how else we can write it? This can be written as the surface integration also. Like this is the end format, like we're doing the volume integration. Now we can convert this into a surface integration also. Okay, so simply using the Gauss divergence theorem, this will be still del P upon del T dV. This I can convert into a surface integration. This will be rho u dot like there will be some n cap vector. Okay, like ds vector can include the n cap vector itself. Okay, n cap into ds, this is what we can write. Okay, so what we are observing is that no, this can't be possible. Okay, like this is not the divergence theorem, like like this can't be present over here, like we are already converting it in back to our normal format. Okay, this format. So yeah, C will be the answer. Okay, we can see that this is matching with our answer here. So C will be the answer for this. So A and C. Okay, so yeah, now let's go to the next question. Here they have told that find the value of, like we have given three vectors. They have asked us to find the value of A such that the vector does not form a basis. Now they have also mentioned that what a basis is. Basis means when each of the vectors are independent to each other. We can write any other vector in terms of all these three vectors in the three dimension. Okay, so they need to be independent. Now here it is telling us that it does not form a basis, so it should not be independent. And when are, like here, three elements, three rows or three columns, when they are not independent, when the determinant is 0, when I put together a matrix with them and the determinant is 0, then they are not independent anymore. So simply what you do is you just put them in a matrix. Okay, and you make the determinant equals to 0, and from there you will find the value of A. So this will be 2 minus 3 A. This will be 3 minus 1 3. This will be 1 minus 5 7 equals to 0. Now like what you can do to simplify this, you can make like two zeros over there. Okay, two zeros over there, or you can find any relation that can basically make the columns equal or the rows equal. Okay, so but like as I am not able to find anything, what I will do, I will just try to make this two element 0. So simply I will multiply 2 times and then subtract, so this will become 0, like what this I am doing. 2 times row 3 row 1 subtraction with 2 times row 3, so this one will become 0. 10 7 A minus 14, this one will also become 0. Row 2 minus 3 R3, so this one minus 15 again 14. Okay, and 321 18. Okay, so yeah, this one is 3 times and we're subtracting it. Yeah, no, this one will be minus 18, and this one is minus 5 and 7 should be equal to 0. So simply it will be 7 times minus 18 minus 14 times A minus 14 should be equal to 0. So what do you do? So this is, if I like cross, this is 2 and this is 9. 9 equals to minus 9 equals to A minus 14, so A will be equals to 5. Okay, so if A is equals to 5, then the vectors are not linearly independent, then this will not form a basis. So answer for this question will be A equals to 5. Now like this may be these are all memory based questions, so it may so happen that few datas are here and there. So yeah, like the procedure I'm telling, method I'm telling, the answer may differ as like the data may change. Okay, so now we have to find this next question. So basically two vectors are given and they are asking whether F1 is electrostatic field or F2 is electrostatic field, or they are not electrostatic field. So how do we understand whether a field is electrostatic or not? So if the curl of that is 0, as I explained right previously, the property of electrostatic field is the integration of around a curve is path dependent independent, so its curl will be 0. So we have to check for the curl of these two. Okay, so we can check from that also that the differentiation of each component, they should be equal. Okay, like, sorry, yeah, they should be equal to 0. So simply you just do del cross f1. Okay, this is y yx, and this is 0. Okay, I missed a part. This will be del x, del y, and del z. Okay, so now like this is 1, this is 1, so 1 minus 1 is 0. Okay, fine. Again, sorry, we shouldn't do like this. We should like first do this. This is 0, this is 0, 0, fine. Then this is 0, this is also 0, fine. Then this is 1, this is 1, so this overall thing is 0. Hence f1 is conservative, f1 conservative. What about my f2? What about my f2? So we'll do the same thing again. Just copy this. F2 is, so okay, sorry, there was a also in front, but a was in front of everything, so it doesn't matter. Like here it was anyway 0, sorry for that. So here also there is a in front, and this is this time ay minus ax 0. Okay, now this one, this is minus, everything else will be same. Okay, like this one is 0. Okay, 0 minus 0. Now this one is 0 minus 0, but here this is minus a, and this is again minus a, like we're doing subtraction. So this is minus 2a, so this will be minus 2a k cap. Okay, so this is not 0, not null vector. So not I meant null vector. Hence this is not electrostatic field. So only f1 is electrostatic field. Option A will be correct. Okay, so next is the double E paper. The double E paper I will solve in the next video. Okay, that will just come after this. So yeah, if you like the concepts and if you like the explanation, then do hit the like button, and I will see you in the next video.